We're going to continue our look at logarithmic functions by looking at two very special logarithmic functions. Let's look at this with a scenario. Suppose that you want to find y when y equals the log base 3 of 9. Now, changing that to exponential form works nicely for us because 3 to the y, remember that's the equivalent exponential form, equals 9. And we all know that 3 squared is equal to 9. Therefore, when y equals the log base 3 of 9, y is equal to 2. But what if we want to find y when y equals the log base 3 of 12? Well, when we say, we'll just change that to an exponential form, we get 3 to the y equals 12. But our problem is that 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 3 times 3 times 3, which is 27. Wait a minute. 3 to the y equals 12 must be between 2 and 3, but what number is it? Well, we think, no problem. We'll just go to our calculator and punch in log base 3 of 12. But if you look at your TI-84 calculator, you're going to see that there is no log base b on the calculator. Now, there are a couple of log bases on the calculator, and that's what makes these two functions so special. And we will be able to actually solve log base 3 of 12 on the calculator, but we're going to have to go through either of these two very special functions. Let's go back and take a look then at what these two special functions are. And these are special, as we said, because they appear on most calculators. The first one is f of x equals the log of x. And the first time you see that, you say, wait a minute, there's no base that's connected with that logarithmic function. And it's because the base is understood to be 10. So if we see f of x equals the log of x, we mean the log base 10 of x. This is called the common log, or log base 10. Now the other one looks even a little more strange. F of x equals the ln of x. That's not even close to our form. This means the log base e. Remember that natural exponential function that gave us so much money when we compounded our interest? Now it has an inverse function, which is the natural log of x, or log base e of x. And we call it then the natural log, and hence the ln. And the inverse of f of x equals then, of course, e to the x, as we've just noted. So let's look at some calculator problems involving the common logs and the natural logs. In this first example, we're going to be looking at y equals the log of 10. Remember, you say, no base, but that's base 10. So it's the common log of 10 is how we would ordinarily talk about that. Well, if we change that to our exponential form, this 10, our base, to the y equals this 10. But 10 to the y equals 10 to the 1 means that y is equal to 1 in this instance. Now let's use the TI-84 calculator to find that. So let's skip over to our calculator for just a moment and look at it. In our calculator, we're going to be looking at, in particular, the common log of 10. And we need to find our common log button. Well, over here on the left-hand screen, in the left of our calculator, the column, we have the log button. And just to remind us that this is the log base 10, we have above it 10 to the x. So we know that is the common log button. So if I want to find the common log of 10, I hit the common log button, hit it, put in 10, close parentheses, hit enter, and as expected, we got 1. So let's go back to our PowerPoint. You can practice on your calculator as we do the rest of these on the PowerPoint. Y equals the common log of 1/100th. Now, if you want to put in your calculator the common log button, you'll get that, parentheses, and instead of having to type 1 divided by 100, you can put 0.01. And when you do that, you're going to get that the common log of 1/100th is equal to -2. Or if you go down to y equals the common log of 25, now this is one that we could not find otherwise than going to the calculator, because really what we're looking for is 10, remember that's our base right here, understood, to the y equals 25. Well, I don't know what number that y would be. I do know that 10 to the first is 10, and I know that 10 to the second is 100, so this must be a number between 1 and 2. Let's find out what it is on the calculator. So hit your common log button, and then 25, put in parentheses, hit enter, and you will get 1.398. Notice it's exactly what we thought would happen, a number between 1 and 2. Now let's go to the natural log function. In the natural log function on the calculator, and let's revisit our calculator for just a moment. The natural log function, if you look, is located again on the left side of your calculator right below the common log. And a reminder that ln is base e is that above it we have e to the x, its inverse function. So let's look at how we would find the natural log of e. This is actually the hardest of those problems. We'll take the natural log, so hit ln and it comes up ln with parentheses of e to the first. So we'll take second and ln to get e to the first, close the parentheses, and when we hit that, we get 1. And again, let's go back and look at our PowerPoint as to why we're getting 1 in that answer. Remember that y equals ln e means that y is equal to the log base e of e. And so that means that e, this e, to the y equals e. But if e to the y equals e to the first, y must be 1. Two more easy problems are y equals the natural log of x. The natural log of 6. And if you hit ln and then put 6 in, you will get the number 1.792. And the final one is y equals the natural log of 3/8. I chose a fraction here because when you put it in your calculator, you hit ln and you'll get your first parentheses, hit 3 divided by 8, close the parentheses, and when you hit enter, you should get negative 0.981. And so we've had some practice with common logs, which means again log base 10, and the natural log, which means the log base e. And those, remember, are our only two calculator logarithmic functions. So consequently, let's go back to that example we started with. We wanted to find what's the log base 3 of 12. And remember, when we put it into our exponential form, which means 3 to the y equals 12, we don't know what y is going to be. And so consequently, we don't have a calculator button for log base 3. We need to change our base. And there are two formulas that will allow us to change the base, and they're very similar to each other, and we can use either one of these, as we'll see here in just a moment. But the first one is the log base b of x equals the common log of x over the common log of our base. Similarly, the log base b of x could equal the natural log of x over the natural log of our base, b. So now we have a way of finding the log base 3 of 12. Using our second formula, it is the natural log of 12 over the natural log of 3. And we can put that in your calculators. Now, this is going to be important because we're going to have to watch our parentheses. So let's go to the TI-84 calculator and actually enter this in to the calculator with me. So if we go to our calculator, let's clear out the information that is on our screen so we get only a blank screen. Remember, we want to put in the natural log of 12 divided by the natural log of 3. So we hit natural log of 12. Now this is the important part. We need to close that parentheses before we hit divided by the natural log of 3. And when we do that, we get our answer, correct answer, which is 2.262, rounded to the nearest thousandth. Now, let's real quickly see what would happen if we had not put in that parentheses. We'd have the natural log of 12. I forgot my parentheses and went straight to divided by the natural log of 3. And notice I get a totally different answer, very close but incorrect answer. So be sure you remember to close that parentheses behind the natural log of 12. Now let's go back and finish this off then. So we just found out that the log base 3 of 12 is equal to 2.262. Or if we wanted to check that, we could take 3 to the 2.262 and it would approximately equal to 12. And that should not be a surprising result if we make a little number sense. 3 squared is equal to 9. 3 cubed is equal to 27. Therefore, 3 to a number between 2 and 3 should equal to 12. Let's practice a little bit with these. On the change of base formula and the TI-84 calculator. If I want, and you follow along on your calculator, if I want y equals the log base 5 of 75, remember there is no base 5 on my calculator, so I look at the change of base. I'm going to use the one with natural logs. Y equals the natural log of 75 divided by the natural log of our base, which is 5. When you put that in your calculator, remember that parentheses after 75, you'll get the correct answer of 2.683. If we do the log base 3 of 75, once again, now we're looking at the log base 3 of 75, change of base, the natural log of 75 over the natural log of our base, which is 3. Or in this case, you could try on your calculator the common log of 75 over the common log of 3, and you'll get 3.930 rounded to the nearest thousandth. Next example, we have the log base 8 of 60. Well, I can do the common log of 60 divided by the common log of 8, and on the calculator we get the result 1.969. Now remember what that is telling us, that if I raise 8 to the 1.969, I should get 60. And that should not be totally surprising because 8 to the second power is 64, a number very close to the one we just found. And finally, if we do the log base 6 of 0.36 or 36 hundredths, we can change the base using our common logs again and take the log of 30.36 divided by the log of 6, and we will get that that is approximately equal to negative 0.570. Now would be a very good time for you to practice several of these change of base problems in your homework.